The electrolysis homework? Sure, have you got it with you? Right, give us a sec. I will have a copy around here somewhere. Okay, so starting off, why does it need to be molten? So melted, so it's a liquid, or dissolved in water, so that's our aqueous solution. Okay, so yes, we need it to conduct electricity, but we're not thinking delocalized electrons, right? Save those for metal and for graphite. Right, what kind of compound is this electrolyte going to be? Right, it's an ionic compound, so it's made of ions. And those ions need to be free to move so that they can carry the charge. Okay, so then our next bit, we're asking about how it is that magnesium is made. Okay, so yes, you're absolutely right, magnesium is more reactive than hydrogen, but for this first bit, we're thinking about a liquid, right? So this is our really easy situation. We've just got the two elements that are in that compound, and they're just going to be made at the different electrodes. So if we've got magnesium chloride, magnesium, that's a metal, so it's going to make positive ions, so it goes to the negative electrode, because remember, opposites always attract. Okay, so positive ion goes to negative electrode. What's going to happen once it gets there? How do we stop that positive ion from being positively charged? Good, it's going to gain some electrons. Okay, so magnesium is group 2, so what kind of charge does it have? Right, it's a 2+ charge, so how many electrons does it need? Exactly, so our positive ion goes to the negative electrode, picks up 2 electrons and discharges. So that's our reduction. Okay, so then we've got to start thinking about this aqueous solution and this gas that we're going to make at the negative electrode. So there's only one gas we ever make at the negative electrode. Right, so that's your hydrogen, okay? So why is it that we're making hydrogen there and not magnesium? Yeah, exactly. So you have to think about your reactivity series and you want to be comparing them. So magnesium is more reactive than hydrogen, and it's always our less reactive ion that's going to be discharged when we're thinking about the cathode, right? So the hydrogen is less reactive than magnesium, so that discharges, so we get the hydrogen gas. A little bit happier now?